A baseball player has a batting average of .32. What is the probability that he has exactly 7 hits in his next 7 at-bats? Whenever we're doing a probability problem, we have a lot of different techniques that are available to help us solve those. One technique is to use a binomial distribution. And if it applies, then that's a very nice, efficient way of calculating a probability. But it requires that there's a fixed number of trials. So we have this person at bat who's going to attempt to bat 7 times. So that's a fixed number of trials. We need to make sure there's only 2 outcomes on each trial. So either he's going to hit the ball or not hit the ball. So that's 2 different outcomes. And we need the trials to be independent. And so we have a batting average of .32 for each time that this player attempts an at-bat, then the batting average is still .32 each time. So we can assume independence here. Which means we're allowed to use a binomial distribution. So the things that we need for binomial distributions are the number of trials, the probability of success, and the number of successes that we wish to observe. So we have a player who is batting 7 times, and the probability of a hit is .32. So then what's the probability that he has exactly 7 hits in his next 7 at-bats? So the probability that we're looking for is exactly 7 hits, which means the number of hits that we wish to observe is 7. Now, because the language says we want to find the probability of exactly 7 hits, that language there tells us that we're going to use the function Binompdf. So Binompdf tells us the probability for exactly a certain number of items out of our sample. So we'll use Binompdf. 7 is the number of trials. The inputs to this are n, the number of trials, p, the probability of success, and last x, which is the number of hits we'd like to observe. So .32 is the probability, and 7 for x. So using the calculator to get our probability, hit second and vars to get into the distributions menu. And you do have to scroll down a bit, but eventually you'll get to the binomial probabilities. There are 2, one's Binompdf and one's Binomcdf, so make sure you have the right one for your situation. 7, .32, and 7 are the inputs in this case. So press enter and we get something that is a small probability. It's changed the format into scientific notation. So we have, let's say, 3.43, I think it was 59. Well, it would round to 60. So let's say 3436 e minus 4. So what that means is 3.436 times 10 to the negative 4th power. So all this is trying to show is that we have a probability that's small, and so scientific notation to decimal notation, we slide our decimal 4 places to the left and get 0.0003436. Now, depending on how accurate the answer is requested at the site, you may have to round a few additional decimal places just so you have some significant figures. If you round to 3, which is pretty common across the site, then technically you have a probability of 0, which It's not impossible for this to happen, it's just extremely unlikely. So I wouldn't recommend just putting 0. I would recommend at least going out to where you have 1 or 2 significant figures. So if you took this and rounded to 4 decimals, or potentially even 5 decimals, just to get a couple of significant figures.